Well, ladies and gentlemen, good afternoon. Let's start about the missing things of the equipment of boats. As we've seen in other presentations, it's possible to reconstruct the shape of the hull of the Lusuria. We have heard how it was constructed and learned about further details like the numbers of rowers, the seats, and the foot stretchers. But what about the rest of the equipment, like the dimension and the shape of the oars? All movable gear was taken off the vessels before they were laid up or later abandoned. Therefore, no archaeological objects were discovered during the fieldwork. Unfortunately, this is also the case with most of the other excavations, where remains of sail and oar, cordage, and so on are seldom recorded. A couple of years ago, a replica of the Bronze Age ship Uluburun, you see it here, was scuttled deliberately near the site where it was discovered. As you can see, the ship with the mast and the sail is sitting upright, more or less on the seafloor. It's here in this row. First, the sail disappeared, then the mast toppled over, and the hull started to collapse. Later, the cargo spilled out. Finally, only few timbers were scattered on the seabed. In a real shipwreck, floating pieces of gear, like oars, would have been drifted away during the process of sinking. Therefore, only few artifacts will be discovered in excavations. Ships were often depicted by artists in antiquity. Here we see a large single-masted cargo vessel entering the harbor, most likely Portus, the port of Rome. We see the sail with the braille lines or bunt lines running through rings, the forestay, the shrouds, which are kept taut by by the help of dead iron lanyards. Here also, so you have some cross beams protruding the hull. Protruding the hull. Another vessel has already entered the harbor. It is secured has already entered the harbor. It is moored to a whole stone. Here you see the mooring line, and one crew and the gangway is rigged, and one person is carrying a load ashore. One of the crew members is entering up the mast, while the other one on the yard is already securing this, the sail. Therefore, we may assume that this is a realistic picture of ships and the way how they are handled. But if you have a closer look, we shall discover some mistakes. On the starboard side, here, the helmsman stands on the stern of the deckhouse, which is the proper position. But on the port side, the helmsman is depicted almost in midships in front of the mast. The braille and bunt lines, here and here in particular, are not running straight from the yard to the lower leach. Instead, they are leading diagonally across the sail in the lower part. Is the top sail here made out of one piece or with a slot in the middle, or are there two sails or even four sails? This means that we cannot treat these pictures like photographs. Instead, we must be very critical and need to some other evidence to prove whether a certain detail is realistic or not. This can be done by using archaeological artifacts or ethnographic historic informations. A comparative analysis of arms and armor of the Mark Aurel column, completed in 193 AD, with archaeological finds shows that some of them were reproduced correctly, but in other cases, outdated ones were shown. We must always remember that an artist wanted to create depictions which were understood by his contemporaries and not used as historically correct in research 2,000 years later. Further, it should be remembered that the Roman Empire was not a uniform state, but some areas, like Egypt, were highly civilized since many centuries, perhaps even more than Italy. Therefore, technical solutions used in the region need not necessarily apply to provinces north of the Alps. As the Lusuria is basically a rowing boat, let's start with oar. From historic times, it is known that the shape of oar differed depending on the type of the vessel. Inland boats had larger shafts and broader blades than those in open waters, which were shorter than with narrower blades. Long shafts give better leverage, but the movements are slower than with shorter ones. Therefore, it is highly unlikely that only one type of oar was used for all kinds of vessels. Here we see four vessels, all belonging to the same kind, carved on the Traians column. Also, four oars in the upper row and only 3 rows in the lower row. The oars just stick out of the hull without any throw pins or any other details. Two ships, on the right, these here, they also look like compound ones with a central shaft and extra blades on both sides. While the other one on the left-hand side, see them here, have been cut out of one piece of wood. Does it mean that the Roman used both types of oars for the same kind of vessels? There's no hint for the length of the oar, nor any other detailed like the shape of the handle. Please note that the helmsman here is clinging to the shaft of the rudder and not to the tiller. It's down here, I hope you can see it, and shown pointing aft. There are other images of galleys just showing rows of oars without any further information. You can see here a couple of examples. Oars are seldom known from archaeological sites. The only exception I came across are the wooden objects found in a former riverbed in Valkenburg, Netherlands, dating to the 2nd century AD. You can see here, these are the blades, and here are remains of the shaft. Some of them could be fragments of oar blades or shafts, but it's not possible to differentiate them from paddles. Some shafts may also belong to poles used for punting, as an end finting for such an implement was unearthed. You see it here. It could be very well belong to this kind of pole. All assumed oars have been cut out of one piece of wood, and there are no hints for compound ones. The oldest evidence for rowing as a means of propulsion in northern Europe are the find from Denmark, from Nydam in Denmark and southern Jutland. Most likely, the technique of rowing was not developed independently in Scandinavia, but was adopted from the Romans. Therefore, it could be worth to have a look at the oars found there, even if the Germanic people did not copy technology unchanged, as the use of kipen instead of thorpins suggests. A total of 4 boats have been excavated, or found excavated, not correct, dated between 190 AD and 330 AD. Unfortunately, none of these oars can be connected to any of the wrecks. Most of the oars were in fragments, but it was possible to reconstruct 3 types. Type 1, it's the one over there, at the length of 2.78 m to 3.03 m. Type 2 is the one in the middle, have a length of 3.15 m to 3.43 m. Type 3, this one here, were probably steering oars. They were all cut out of one piece of wood with narrow blades. You can see them here. There are no marked transition between the blade and the shaft, nor a distinct handle. You see over there, there's nothing particular about the handle. The blades of one blade of type 2 has a rhomboid cross section. Sorry, this is the one in the middle here. The type 3 has thicker shafts in the upper part, which are almost square in section. You can see that here. If you go even further in time and space to the Viking Age boat grave of Oseberg, Norway, which dates to the first half of the 9th century, we see another shaped oar. It's the one over here. The small blade leads onto the shaft, which thickens to the end towards the handle. That's counterbalancing the weight of the oar outside the hull. In his reference book about mast and oar, published in 1797, Steele gives the dimensions of oars of various vessels. Smaller boats were equipped with oars with asymmetric blades, while larger ones had straight blades. Probably the first one were used for fast transport of passengers and goods, while the other ones are for heavier vessels. As they were called sweeps, they were most likely operated standing. The length of the oar is set in relationship to the breadth of the boat. Unfortunately, the table stopped at 1.75 m 75 and 2.10 m. Sorry, here, which is considerably less than the breadth of the Lusuria. Further, there's not well defined where one part, such as loom and body, you see a length are given here, end or start. There's also concerned the length of the handle. I mean, starts the handle here or up there. So there's a difference. The same as also here. Most likely it's only this part where it's not only this part which is the actual handle. Most likely the point of start with loom starts to pattern in this in this area here. As we have seen, the handle of the oars are to give hold to for two hands. This is also the case with traditional working boats, which are nowadays used for recreation. On pictures of whaleboats of American designs taken in the Azores, when whales were hunted up to the 1980s in these vessels, one can see that one hand encompasses the handle, while the other one rests on the shaft. Let's go on with rudders. Ship in Antiquity was steered by two side rudders on each side of the stern. The rudder itself was made out of a shaft, you can see it, and two blades. You can see it here, you can see it here. The rudder was controlled by a tiller. We've got here one. There's also the tiller, which could point in different directions. The actual area where the rudder is mounted to the hull, unfortunately, is concealed by a blind. Some sailors point aft. Can you see this picture totally? Because this one is missing here on my presentation because the photos are there. But this the tiller is pointing aft. Here it is pointing inward, and there are also angled one, as you can see here. So there's a great variety. In the harbor of Olbia, Sardinia, Italy, 3 round tapering timbers, we have them here, the other one over there, with slots in their thinner ends dating to the 1st century AD were discovered. Most likely the blades were fastened to this part of the shaft in the well-known mortises and tenon technique. You see here the little slots, and then the blades were fastened in the known technique. At the other end of the shaft, there's a large slot indicating that the tiller was directly in line of the blades. You have it up here, so it must either point forward or backward. These were the rudders of large seagoing vessels, as the size is showing. A different kind of rudder was discovered at Madras de Lorence, France, dating to the end of the 2nd or beginning of 3rd century. It was a shallow-hulled vessel which suited the shoal waters of the delta of the River Rhone and the lagoon of the Camargue. The rudder has no shaft, but it's a thick board. You can see it here, it's one board with no shaft. In the lower part, 5 dowels were passing lengthwise through the rudders. You see them here. Unfortunately, the find is not fully published yet. Therefore, it must remain open whether they were part of the original construction or whether they were used to repair a split in the wood. Split is indicated here in this line here. Further, there's a recess which was protected by a metal sheet. No. This area here. Near the top, one can see a round fitting of unknown purpose. This here, and a mount with a hole at one end. Here, a tiller pointing forward is and slightly angled inboard. You see, this would be straight. This is slightly angled inboard. Was nailed to the top. It's up there. At the port side, over here, the hull was strengthened by additional board as protection against the strain of the rudder. Unfortunately, it's only this reconstruction was published, which is totally hypothetically, and I don't know how to understand it. Here, a couple of ropes, but the rest is not understandable. By the wreck of Brugge, Belgium, dating to 189 plus minus 80, rudder was recorded. The vessel belongs to the Blackfriars type, which were cargo ships in the English Channel and the North Sea. As they were constructed in a technique unknown in the Mediterranean, the shape of the rudder could go back to a local tradition. It is made out of one piece of wood. This is the rudder here. A slight rebate at the beginning of the blade or shaft, depending which way you're looking, indicates that the rudder was fixed here with a rope, a piece of leather, or the metal one. A slot in the top of the shaft here shows that the tiller was pointing at right angle to the blade of the rudder. A similar rudder was discovered in the castle of Newstead, dating to the 1st century AD. Here again, the tiller is oriented at right angle to the blade of the rudder. At the tip of the blade, there's a notch of unknown purpose. Unfortunately, the way how the rudders are mounted to the hull is never depicted because the area is usually protected by a blind, as I've already told you. Therefore, Mott could only give a hypothetical reconstruction in a thesis about the history of the rudder. You can see here 3 examples. None is convincing, and I don't know how they actually should have worked. The only exception we can see on the triumphs column, where the rudder is fixed to the hull by a sheet of metal or piece of leather. You have it here. In Indonesia, side rudders are still in use. At the stern, there are 2 cross beams with notches. You can see them here or up here, or a timber pointing aft, which is here at the lower part. Further, there's a stick hanging down on 2 ropes. This is a stick hanging down on 2 ropes. The head of the rudder, you have it here, is fixed to the upper beam with a rope. The lower rope is passed around the back of the rudder and is tightened by the stick acting as a lever. You can see the construction here. One of the advantages of this system is that in case of emergency, the rudder can be undone quickly when hitting an obstacle, or when hitting an obstacle, most likely the rope will part, but the rudder will remain undamaged. Even if this is a practical solution, this does not include that other ones were used as well in antiquity. The relief showing the vessel entering the harbor of Portus, which I've already mentioned, there are 2 holes in the blade of the rudder next to the shaft. You can see here the 2 holes. And there are 2 holes and the 2 ropes are leading through. Perhaps these ropes are leading on to the deck, which is shown here. A similar evidence can be seen on the triumphs column. I hope you can see it. There are 4 holes and a crossed line through it. The purpose of this construction is unknown, but perhaps the ropes were used to raise or lower the rudder to control its depth, but other functions are possible. Let's go on to square sail. The mast step in the keelson and the notch in one of the seats indicate that a Lusuria also carried mast and sail. Several images of sailing ships are known, but they nearly all represent seagoing merchantmen and no military river class. Usually they are a single-masted vessel with a square sail. Here's the square sail and 1 mast. Some also carry a foremast known as the Artemon, but it's here that at the top of the mast there's sometimes some kind of knob. Further, we can see standing and running rigging. Here we have, well, some kind of shrouds. There we have here we have braces. We have sheets. We have stays, and so on. Surprisingly, there's no depiction of a tack. This is the counterpart to the sheet which is needed to trim the square sail properly when sailing close haul. It would run from here forward or from here to the bow. The square sail could be reefed and furled with brail or bunt lines running through rings which are sewn to the sail. You can see them, this construction here and here also. In seagoing ships, the members of crew had to climb up to the yard to secure the sail. You can see them here, up there securing the sail, and here the bunt lines are pulled by the crew. But this was not necessary in smaller boats. You can see it here. Apart from the bunt lines running up and down, horizontal strips are depicted, representing either seams or bends to strengthen the cloth. In spite of these details, the images do not give all information, and it is therefore impossible to obtain knowledge about dimensions of the mast or the proportions of a sail. Let's go on with mast. As masts break during the process of wrecking are among the parts of the boat of the gear which disintegrate first after sinking, only very few masts are known from excavations. In the harbor of Olbia, Sardinia, Italy, a lower part of the mast was unearthed dating to the 1st century AD. Here you have got parts of the mast and here the drawing. Its size indicated that it belonged to a large seagoing ship. In the trunk, there was a row of notches here, which probably housed wooden mast steps. You can see them here in a wooden mast step. Such climbing instruments can be seen at the mast of a riverboat. Here. It is not very likely that the lower part of the mast of a riverboat, which can be lowered and raised as in Lusuria, looked similar to the foot of the mast of Olbia. This is a very massive part, as you can see here. Therefore, it cannot be used as an example for a mast of the Lusuria. The already mentioned wreck site of Brugge, also parts of a mast were discovered. The fragment was still 8.30 meters high, and the top was broken off. In the upper part, for a short length, it was square in diameter. It is up here, as you can see it here. The square diameter with two slots. Most likely, they hold sheaves for a pulley, which acted as a halyard. Another slot with a slightly different orientation up here was further up the mast. Surprisingly, this is not a right angle to these two slots, but slightly in say 45 degrees. In the Black Sea, a well-preserved wreck with a still standing mast dating from 410 to 520 AD was recorded by the cameras over here. On the top of the mast, there's a square notch up here, and which could have held a knob or some other decorations. Steel gives information about the length and the diameters of mast in relation to the breadth of the hull. But these figures need not necessarily apply to all vessels. For example, a Ness-Yole, you've got a picture here, on the Shetland had a mast of 4.26 meters length and a diameter of 4.62 centimeters. According to the recommendations of steel, the diameter should have been 8.89 centimeters. If you look at ethnographic photos, we can see mast and sail which will not meet any safety regulations, like this ferry on the boat of the Upper Nile here. This means that masts used in antiquity may have different dimensions from those recommended today. Let's go on with sails. A mummy in Egypt was wrapped into a cloth which was identified as the remains of a sail dating to 150 plus minus 50 BC. According to some authors, it derives from Theben. Other claims it was found in Edfu, and some are calling it the lion sail because it was analyzed in that museum. Only fragments are left. You can see here the various fragments, but one can see that it was reinforced by webbing strips which were colored red and blue at the sides. Here you've got larger fragments, and you see the webbing running through. Some were running parallel to the seams, others at right angle. The sail and the reinforcement webbings were woven of the S-spun flax. At the crossing of two ribbons here, a fragment of a wooden bracing was hewn, thus indicating that the sail had once been, that the textile once has been sail. Remains of sail and part of rigging, together with other cordage, were recorded in the ports of Myos Hormos and Berenike. They're both up here at the end of the Red Sea, Egypt. In both ports, goods from India were discharged to be transported on pack animals to the Nile. These caravans also needed rope for fixing the load on the animals and for tents. Rough fabrics similar to sails were also used for tents or to wrap the merchandise. Therefore, it is difficult to decide whether fragments of cloth or cordage found in the former harbor really belong to ships. The sails were made out of cotton woven from Z-spun yarns. Though cotton may have been grown in Egypt in the 1st century AD, Z-spun textiles are only known from India. This means that the sails may have been produced in India. In Berenike, a fragment of the sail with a crossing reinforcement webbing was found dating the 1st or 2nd century AD. You see here the fragment and here the drawing. The sides of the webbing here and here were dyed blue. The sail had been damaged during its use and had been patched. You can see here the patch or here the drawing. The two wooden braille rings over here, together with another piece of sail, is also recorded. A larger fragment, in the harbor of Myos Hormuz, several fragments of sails were observed, dating to the end of the first beginning of the 2nd century AD. One strap with a still attached braille ring was reinforced by a strip which was not tabby woven but twill in fishbone pattern. We have got here this fragment from the back side. Here we have the braille ring, and this is from the other side. Here the braille ring, and here we see the reinforcement webbing in fishbone pattern. One larger fragment gives hints for the standard of sail making. The photos on the left the photo showed the left side of the drawing. We have got here the webbing and here the self-bend and weave. This is this area here in the drawing. It is the lead of a sail, though it is not known whether the upper or lower one. Stray strands of rope are poking at irregular intervals out of the seam. Further, there are interwoven thicker threads called self-bend and weave. We have them here. In addition to the webbing strips here and there. Among the various bands or strips which not necessarily all belong to sails, there were some which were made of S-band flax. In one seam here, we can see a rope as a reinforcement. Another fragment, a kringle is sewn on, we have it here, which may have held a line to control the lead of the sail. On the other hand, it could have been part of the tent. Several fragments of rings made of horn or wood were discovered together with the sails. They have two small holes which were used to sew them on the sail. Through these rings, the braille or bund lines were running, as it can be seen on various depictions. Rings made out of lead, we have them here, were also observed in several wreck sites, and some may have been served for the same purpose. Square sails were not the only type of sails used in antiquity. There are a few images of sprit sail. The oldest one dates to the 3rd century BC. That's over here on this side. It's a rectangular sail which was set on the back side of the mast. The upper lead is spread by a spar known as the sprit. You can see it here or here, and also there. Which runs diagonally from the lower part of the mast to the corner of the upper and aft lead. The sprit and the upper part of the sail are controlled by two wings additional to the sheet. We have got here the two wings. The sheet is down here, and here this is a look from the back into this depiction here. We have got here the sprit and the two wings. If the depiction of sprit ring boat are correct, this type of sail was used for small boats, for small vessels only. Sprit sail were used on many kinds of vessels until the end of the days of sail. Sail handling can be done by two crew members, one for the sheet and the wings, and the other one for furling the sail. If the sprit is shorter, like this one or this one here, and does not reach the foot of the mast, this can be done fairly easy by undoing the foot of the sprit, because then the sail will collapse behind the mast and can be secured by a short length of rope. Further, there's the image of a Latin rig. You can see it over here, the triangular sail, dating to the 2nd century AD. Unfortunately, no details of sail and rig are shown. The Latin sail is set from a diagonally rigged spar. Yeah, we've got it here. The forward end of the yard and the sail are controlled by a tack rope. It's not really depicted here. This is misleading, this line. It should run here. A tack rope or tackle, and the upper part by a vang up here. Finally, there's a sheet down here. The sail is set on the lee side of the mast, and often there are movable shrouds, which are only on the windward side. In smaller boats, the sail can be raised and lowered with a yard. In larger ships, the sail is brailed up to the yard and is secured by the crew climbing up the spar. In some smaller vessels, the upper part of the sail is not to the yard directly, but to rings which can slide up and down the yard. You can see it here down there. This arrangement can still be seen on the River Nile in Assur. The Latin wreck is not easy to handle when the ship must tack or jibe. The last word is usually preferred in larger vessels. For jibing, the ship is put before the wind and the sheet is let fly. You can see it here, down here. This is the original course. Then the sheet is let fly up here. The yard has to be put in an upright position in front of the mast and pass to the other side. You can see here this matter of several people are also here in a smaller boat. And the sheet, while the sheet is shifted round to the other side. On the neck, the sheet is hauled and the shroud is set on the other side if it's a movable one. For tacking, the yard has to be shifted round the aft side of the mast. But there are several variations how the sail can be handled. For instance, when running before the wind, the sail can be set before the mast, so we see it here, or behind the mast. If the yard is angled very steep, as here in the example from the lower Nile, no wangs are needed, as on the boat of the lower River Nile. The sails can be set either inside the shroud, as we can see it here, or outside, and the shrouds are fixed and need not to be shifted. The sail is not shifted when tacking, and to the lee side, and therefore pressing against the shroud when they are on the windward side, as you can see it here. All these three types of sail have advantages and drawbacks. Spare sail are top-heavy because of the weight of the yard and need several trained crew members for handling. On the other hand, they are very easy to handle when running because the sail will not come back when the sun suddenly shifts from starboard or port to port or the other way around, which is not uncommon in rivers. Spritz sail have less wide aloft and can be handled by two persons. On the other hand, when running before the wind, there's always the danger of an unintended jibe, which can cause damage. The Latin sail is also top-heavy. Depending on the arrangement of the shroud and the wangs, it only needs one man to handle. But similar to split sails, accidental, uncontrolled jibes are very dangerous. For setting sails and other purposes, tackles are needed. From various sides, remains of blocks are known. The shell of the single block is made out, single sheet block is made out of two halves. Here you have got the two halves. The sheath and the pivot are made out of one piece. It's out down here or down here, because you also can see it here. A rope to the two halves of the shell have a groove outside on the outside for the eye of the rope. Here you can see the groove, and also it's here indicated. This rope, together with the sizing, is holding the shell together. You can see it here. This is the eye, and here's the sizing. Therefore, there are two holes there. If the rope is, the dimensions of the block are linked to that of a rope. If the rope is too thick, it will jam in the shell. If it's too small, it will jump off the sheath and will get stuck between the side and the sheath of the shell. For heavier loads, two sheath blocks are necessary. In this case, the shell is cut out of one piece of wood, and while the sheaths and the pivot are made separately. Here, we have got the sheaths and the pivot. The hole in the middle of the sheaths has to be larger than the pivot, as it has to turn freely. Here are a couple of other examples for blocks and sheaths, just showing the variety, and there are also single sheath blocks which are made not of two, where the shell is not made of two halves. To lift extremely heavy loads, such as yards of large seagoing merchantmen, complex tackles are necessary. Here is a lower block for such a purpose with 6 sheaths, 3 up here and 3 down there. To allow the rope running freely, the sheaths are aligned in different directions, as you can see here. And these are photos of the find. Toggles of various sizes were also used for connecting ropes, which have to be undone easily. Here as a toggle. Perhaps this pin served for the same purpose. Here you see reconstruction, how this could have been handled. Further, though the excavator thinks that this was a belaying pin here. The function of this spreader is not known, but perhaps it was used to control the leach of a sail or is linked to an awning. To achieve the necessary tension of shrouds and stays, dead eyes and lanyards had to be used. The system can still be seen on traditional rig boats today. See it here. The array of the holes, deadlights had 2 or 3 holes depending on the size of the standing rigging they were used for. Here they have 3, 2, and so on. Apart from the array of the hole depends on its use. Apart from the large hole, there are 2 smaller ones which hold the sizing to fix the rope to the shroud and the stay to the groove. We've got here the 2 holes, and you can see here the sizing which holds the rope, and you see it here as well. This rope here, in this case, is not spliced around the dead eye, but the 2 parts of the eye are sized together. You can see here the sizing. Underwater, ropes disappear fairly quickly, and therefore they are rare among archaeological finds. The few known examples show that they belong to the type of laid ropes. First, the fibers were drilled together to yarns. These yarns were joined to strands, and finally 3, sometimes only 2 or 4 of them are forming a rope. The turn of direction was changed in every stick. Any available long fiber flans were used for rope making. The wreck of Magan Mikael, Israel, dating to the 5th century BC, a conglomerate of ropes was discovered. It consisted of 3 ropes, 2 on one side and 1 to the other, bound together in a kind of reef knot. This is the photo of the situation of the excavation. Here you have got the rope on one side, and here you have got the 2 other ropes on the other side, and here you can see how they were bound together, which I would call a reef knot. In the already mentioned harbor of Myos Hormuz at the Red Sea, several fragments of ropes were unearthed. Again, it is open whether these ropes can all be connected to ships or whether some of them were used for tying goods together on the back of animals or for tents. Let's have a closer look at some of the cordage. All these 4 ropes form an eye, and you can see it here. This is the eye, this is the eye, and that should be the eye. And the shorter part is sized to the larger one. You can see it here fairly clear, here and here. This technique can still be seen today and is used to fix the wires of a shroud around the dead eyes. I hope you can see it here again by a modern boat. But this is an indication that splices were not known, or at least not common in antiquity. These 2 ropes had been worked into a ring like this one, and then connected in the middle, forming a kind of figure of 8. You can guess it here, and this one you must fold it over to show it. These kinds of strop or grommets were used for connecting blocks with spar or similar purposes. You can see it here or up here, something like that. Here we see 3 ropes laced together in an unidentified knot, perhaps a kind of Matthew Walker knot. The use of this rope construction is not known, but possibly they formed a bridle or crowfoot. Well, let's sum up. Our knowledge of oars is totally insufficient. Rudders, insufficient as well, particularly the way how they were mounted to the hull. Mast, acceptable, but their dimensions are rather vague. Sails, weak as far as the kind of fibers were used for fabric, for example, wool. Square sail, good, in particular how they were set, reefed, or furled. Split sail, acceptable, but some details are vague. Latin sail, totally insufficient. This applies to the handling as well as the way the yard and the sails are set. Blocks, very good. Standing rigging, acceptable as far as the setting is concerned. Ropes, limited. Were there any ice splice? What kind of materials was used apart from plant fibers? Something like walrus skin or moss, etc. Well, I've come to the end of my presentation, and I would like to thank you for your attention.
Thank you, Timm Weski. Thank you.
Can you see me?
Pardon?
Yeah.
Now we are coming to the discussion. Are there questions? Are there any questions? May I start?
Yes.
Probably a stupid question, but you mentioned in one sentence that there are evidence for coloring of sails, at least small parts. What do you think? Are these indications for the coloring of the whole sail, or the blues coloring especially? For example, as you well know, Vegetius said the cordage and the sails are colored blue. Or is what do you think? Is this only sectionally or in exceptions?
Well, there are only very few sails, and they all derive from the Red Sea ports. So no, the sail from line as well. They all derive from Egypt, and in that case, only the bands, which are tuned to the sail, are colored on the outer sides, either blue or red, and then the so-called band in weaving. There are cases where these thicker threads were also colored. So this is not the whole sail is colored, but it might have some, well, colored impression. But I don't know. I've only seen black and white photos. That's the problem. And what kind of color were used is also not analyzed.
Okay. I was told there's a question in the chat. One question is said, there's the question, is it possible that the sails have been made of leather too? As, for example, we know Caesar is saying.
Yeah, well, this is an old question, and I think that Ronald Bocchius is much more competent in that case. There are perhaps two depictions of such a sail from the northern provinces, from the River Rhine and the River Mosel, but there's no archaeological evidence for that.
Ronald?
Yeah, that's true. There's no archaeological evidence on that. It's just written evidence, and I would say we should also consider the periods, the different periods. That also concerns the problem of the coloring. Yeah, Hellenistic evidence of an individual, certainly individual find belonging to an individual boat or ship could be, of course, an example to copy, but nobody knows whether other individual boats, especially those are of more than half a millennium younger age, would cover the same. I would say there are limits of reconstruction. Limits, a lot of limits. I share many of the meanings, but I would say the comments of Timm. We have a lot of evidence, but archaeological evidence, carefully has to be selected and used. And I would say we must not be shamed if not everything can be answered.
You're perfectly right.
But Ronald, how would you estimate the Caesar's comments on the Celtic, I think, sails? Yeah. Yes.
Well, an expert. I'm not an expert of sailing. I'm a sport sailor. Yes, but I would say it's nonsense to make, especially with seagoing ships, it's nonsense to make a sail from leather because it becomes wet, and then the profile of the sail will alter, and that might cause a lot of problems. I would never sail on a ship on the Mediterranean with a leather sail. But, however, leather was used as well, fittings or to protect the ropes and the like. What Caesar mentions might be focused on inland boats, on Celtic inland boats.
Okay.
And this is another story, of course. Well, actually, there are two depictions, very different depiction. One is a wonderful colored mosaic from an ancient place near Mainz, Bad Kreuznach, and the other is an comparable relief, stone relief from Jünkerath, also an ancient place in the Rhineland area, and both actually show a very specific rig, sailing rig, certainly of an inland boat, a rig with more than one yard arm, horizontal spars, and I think in Antiquity, in the Roman provinces, as different shipbuilding system existed, also different rigging system were known by the local society or transformed into the Roman period. But I would never use this specific, say, Celtic Romano-Celtic rig, which seemed to be well, part of a regional system of rigging system of native boats. I would never use it for the reconstruction of something official, of a military boat of the late Roman army. What let me add one aspect or concerning the problem of the rigging. Nobody knows what system was used, but if we also have to look on practice, on traditional boat practice, in the area, of course, because of similar weather conditions, or the more or less the same weather conditions, the landscape, the topography, etc. If you look on the younger images on sailing ships, on boats on the Rhine, I mean late medieval and early modern depictions, especially for the late medieval ones, you always see square-rigged ships. Yeah, they are very prominent, nice and realistic. It's realistic depictions, showing heavy cargo ships with square rig, but they always are sailing upstream, and they are sailing downstream and going upstream by towing. So if we look, when we look on the Mainz material, on the shipwrecks, and if we look on especially on the geometry and the proportions of these boats, of this boat type, we are talking about one of a specific boat type. And if you look on the cross section of the boat, everybody, especially Timm Weski, should say this is not a sailing boat. This is anything but a sailing boat. But old vessels can also use sail rig as an auxiliary method as a support for propulsion, but not as the primer propulsion system. So say the square rig is the most simple, the most simple system to use wind to, well, to drive a vessel downstream with the support of the stream itself, of course. There are other questions connected to this, of course. Yeah, the many questions. For instance, the height of the mast, the length of the yard arm, etc., etc. I give you two examples. Examples derived from our attempt to find an answer for that. Yeah, let's say in that way. The length of the mast probably can be retrieved from the length of the boat, and especially from a characteristic well, a kind of storage inside the boat. Behind the afterwards the mast, there is between the thwarts, between the accommodation units of the oarsmen, there is the only empty space above the keel where long spars could be stored in case of boats were rowed, were propelled by rowing. If you look at this space, it's more than 7. I'm not quite sure. It's more than 7 meters in length, and this is more or less the length of the mast we made in the early 90s. What concerns the length of the yard arm, there's a simple rule from traditional sailing and ship design also. Yeah. Traditional ship design or ship construction of sailing ships of the Clipper period, for instance, the length of the yard arm shouldn't exceed 2.5 meters of the maximum beam of the ship body. Yeah, that's what we did. If it exceeds much more this length, you get problems with the handling of the square rig for the braces and the sheets. Yeah, but this is just a rule of the thumb, not more. Yeah.
Arnold? There are two questions from the audience, Michaela Reinfeld and Lukas Müller.
Yeah.
Michaela Reinfeld.
Yeah, thank you very much, and many thanks for your talks. Actually, part of the question is already answered by Ronald, so thank you very much. But I wanted to ask if there's something like a rule of thumb for at least the same type of ship. Let's say if you have a flat bottom, river going wooden ship with a very long mast and a square sail, if you have at least the length of the ship or the length of the mast, how can you get a clue about the size of the sail? Is there a kind of rule of thumb?
No, there isn't. There is no rule, because the decision to decide about the size of a sail is a decision of the shipbuilder, and to use that is the decision of the skipper. Yeah, you can hang on a boat whatever you have. Yeah, but in case of strong winds, you have a problem. Yeah, and it is well known that especially in inland navigation, rigs looked different to those from seagoing vessels, of course, because you have the it depends on the landscape. You have to catch the wind by higher masts, by smaller by sails of smaller width, of course. Yeah, but if the sail can be shortened as the ancient rigging allows, you can decide to use a bigger sail, and you calibrate the size of the ship, the size of the sail, well, on board of the ship. Yeah, it's depends on the wind, but there's no rule. Yeah, there's no rule on it. Well, it's not quite correct what I'm saying. I forgot. There are some rules from sport sailing, of course. There's the comparison between the displacement of a hull and the sail area. Of course, there is, for instance, what's called the sailing in German terms, die Segeltragezahl. Well, it's a rule similar to that of on the length of the yard arm. The very sportive boats have very large sail areas and other ones less, and very bulky ships also larger ones. But it depends all the time on the geometry of the boat, on more physical data. Yeah? Without having these data, you can say almost nothing. Yeah, yeah, and we do not know what ancient skippers decide. Were they willing to well, more on the side of security, or more of the other guy? Yeah, who have well, I don't know. Yeah.
May I add something?
Oh,
do we have any evidence about the use of different sails? I mean, for different wind conditions, like storm or nice weather?
You mean in the
yeah,
ancient sphere? From my remembrance, not, perhaps with an exception. There are very few, I would say, unique depictions. There's one shown, I think Timm showed it also, looking like a balloon sail, so a fore and aft sail with oversized. Yeah, it could be, but we have no evidence, no hard evidence on that. But I could well imagine, yeah. Because they were, I think, ancient skippers were not worse than modern ones. Yeah. I don't know. Ask the historian.
All right, thank you.
Yeah. Thank you. Thank you. Lukas Müller, you have a question?
Yeah. My question was about the rudder, because when we talk about larger cargo ships, like the ones sailing from Rome to Alexandria or something, is it in any way practical to use the two rudders that we have on the depictions, or did they use more, or other types of rudders? Is there any source about that, or anything which we can deduce from something?
Yeah, they're different. There's different information on that. First of all, you have to consider that sailing ships need two side rudders, because depends of the heeling of the boat, and one on the windward side probably wouldn't have the rudder stick into the water, say forget the right terms. Without two side rudders, you cannot sail. You couldn't sail in antiquity, at least not in the coastal or area. There's written evidence on very large ships having more than two side oars. It's the 40 of this is Athenaeus, I don't remember, but these are exceptions. Very large boats, probably ships, probably with two hulls. Yeah. Another aspect, and this could be more interesting for us, is that ancient depictions of inland vessels actually show an after rudder, yeah? A single rudder at the aft of the boat. But these boats or manned seem to be flat-bottomed boats having, well, a kind of rudder which could also be used for slow propulsion in harbors or so. Yeah? But there are different types. That comes from pictorial evidence. Yeah? But this is not an open question in case of the Mainz boat reconstruction, because the device to mount two side rudders is preserved with more than one brake.
Okay, thank you.
Are there any questions? That I see. Okay. May I add one question to Timm Weski? You are demonstrating the handling of the Latins sail. Yeah, the one type of sail which is attested very rarely in these early times. And I was wondering about the shrouds. How can you imagine the handling of the Latin sail by when aft winds from back are coming with both shrouds are when both shrouds on both sides are fixed, like in the Neil example. Yeah.
Well, there are two ways to rig the squares. The Latin sail. You can rig it outside the shroud or inside. If you rig it outside, it doesn't make any difference. Yeah. And if I remember rightly, I don't have any photos, the small boats on the River Nile, which are used as felucca, the sail is rigged on the outside. And therefore, if you sail on the other, if you tack or drive, you sail on the other boat, the sail is pressing against the shrouds. Yeah. But on the other hand, I showed you one of the big boats and sailing before the wind. And there you could see that, okay, that's boomed in that case. And in one case, it was inside the shroud and it was just pressing against the shroud from the aft. It's both possible.
Okay.
But I would never use on a small boat like the Lucia the system that the shrouds were moved around on a river, because you have to tack fastly and you can't do it with removing the shrouds each time.
Okay. So thank you. Are there any questions? I'm looking. Not that I can see. Then I would like to thank the experts for giving their papers, and I want to thank to the audience for the patience and for the participation in the discussion. That's it. Thank you so much. Goodbye, and see you soon. Hopefully in better conditions without COVID-19 and so on. Hopefully in person. Thank you. Bye. you.